Okay, guys, looks like we are live. And today we've got a very special guest with us, Dr. Jason Lisle. Dr. Lisle, thanks for giving us your time today for this very important show.
My pleasure.
Dr. Lisle, you graduated from summa cum laude from Ohio Wesleyan University, where you double majored in physics and astronomy and minored in mathematics. He also graduated work at the University of Colorado, where he earned his master's degree and PhD in astrophysics. While there, Dr. Lisle used the SOHO spacecraft to investigate motions of the surface of the sun while looking at solar magnetism and subsurface weather. His thesis was entitled Probing the Dynamics of Solar Supergranulation and Its Interactions with Magnetism. He has also authored a number of papers in both secular and creation literature. I think the best question to start off this entire interview with would be, is Genesis 1 through 11 actual history?
Yeah, it better be. All the other books of the Bible refer to it as literal history. Jesus Christ is descended from Adam. You can read the genealogies there in Matthew and in Luke. And I think it's the one in Luke that goes all the way back to Adam. So yeah, it's real history. The way it's written too, it makes frequent use of what's called the Vav consecutive, and that's where you have and this happened and that happened and that happened. It sounds kind of weird in English, but and followed by a verb in the original Hebrew word order. When you have a sequence of that, that's always indicative of literal history. So there's no doubt. And frankly, Genesis 2:4, where it says, these are the generations of heaven and earth. These are the birthings or the origins of heaven and earth. It's telling you that this is history. This is how the universe began and how it came to be the way it is today. So creation, the flood that occurred at the time of Noah, Peter alludes back to that as real history. It's something that happened, and it foreshadows the coming judgment by fire. So of course, yeah, it's all real history, and it's theologically important that it's real history because it's in Genesis where we learn that death's the penalty for sin. That death came into the world as a result of Adam's sin. And if that's not real history, then why did Jesus have to die on the cross? So you see the gospel message even goes back to the literal history of Genesis.
What would you say are some of the best lines of evidence against an old universe and for a young one, Dr. Lisle?
The best ones, we have the birth certificate of the universe. The Bible is a history book that records when the universe began. In the beginning, God created the heaven and the earth. Human beings are made on the sixth day, and from adding up those genealogies and so we get so-and-so. You find that it's about 4,000 years between Adam and Christ's earthly ministry, which was about 2,000 years ago. So something like 6,000 years. That's the best evidence because it's recorded history. Now, I think there are lines of scientific evidence that confirm that history, that confirm a recent time scale. But that's the best because it's history, right? I mean, if you want to find out when the last World War happened, you read a history book. You don't do a science experiment and mix chemicals. It might confirm that, but the best way to answer a history question is with a history book. That being said, I think there are a lot of lines of evidence that confirm that. Lots of stuff in space. That's, of course, my area of expertise. There are things that can't last billions of years. Comets, for example, they can't last even millions of years, really, because a comet is made up of ice and dirt, and it orbits the sun in an elliptical path. And when it comes close to the sun, that icy material is blasted out into space. That's what forms a comet's tail. We had a really nice one this last summer, actually. I hope you got to see it. Nice naked eye comet. It was very beautiful. But every time you see comet, it's getting smaller. It's losing mass. We can calculate the amount of material that's there. We can calculate the rate at which it's being depleted. They can't last millions of years, 100,000 years maximum for a typical comet. In fact, in my doctoral research, I used the SOHO spacecraft, and it looks right at the sun. And one of the instruments on it blocks the sun and looks at things that get real close to the sun, like comets. And I've seen comets that have gone behind the sun and been totally destroyed in one pass. So they don't last millions of years. And my secular colleagues don't even dispute that. They would say that there must be some kind of source of new comets. They call it a Oort cloud. There's no evidence for that in our solar system in terms of observational evidence. Lots of things like that. The rate at which magnetic fields decay. Magnetic fields don't last millions of years. Magnetic fields are caused by electrical current in the core of a planet like the Earth, and that has been decaying. We know Earth's magnetic field's been decaying. We've been able to measure it for the last almost 2 centuries. It's definitely decaying. It seems to be an exponential decay, which is what we would expect on first principles. It's not oscillating, not today anyway. It might have during the flood, but other planets as well. There's evidence that Mercury's magnetic field's decaying. Jupiter has an enormous magnetic field. they don't last millions of years. With Earth's magnetic field, based on the current rate of exponential decay, you run it back 60,000 years ago, it would have been stronger than a neutron star, which is enough to rip the atoms of your body apart. And so it can't be anywhere near that old. It's not even a million years. It can't be anywhere near that old. Or carbon dating. A lot of times people think carbon dating gives the millions of years. It doesn't. Now all these dating methods are based on certain assumptions, but the fact is a lot of them give ages. Even if you assume secular principles of uniformitarianism and naturalism, a lot of them still give ages much less than the billions of years, including the fact that C14 has been found in things like diamonds that are buried deep down in layers of the earth that are well insulated from cosmic rays. C14 doesn't last even a million years. It decays very quickly. And so the fact that you find it in fossils and in just about everything that has carbon in it is a strong indication that the earth is not anywhere near billions of years old. Lots of stuff like that.
Wow, that's a great response. A lot of good information there, Dr. Lisle. With the comets one, for example, that limits the age of the universe, I've seen, as you pointed out, this Oort cloud that's constantly being invoked. But like you said, this Oort cloud is not actually based on real observable empirical evidence. Is that right, Dr. Lisle?
Yeah, I mean, it's the idea is with an Oort cloud and it's named after Jan Oort, the guy who came up with the idea. The idea is that there's a vast supply of potential comets out beyond the farthest planets, out way beyond Neptune, but we couldn't possibly detect them at that distance. There's no way to detect them. So it really seems to be a rescuing device, a hypothesis that the secularists have invoked to protect their worldview from what appears to be evidence to the contrary. And they'll say, well, you can't disprove an Oort cloud. And that's true. I can't. It's undetectable. But there's no evidence for it either. They'll say, well, we find evidence of Oort clouds in other solar systems. Not really. We do find solar systems that have some kind of debris orbiting them, but we don't know that it's billions or trillions of comet nuclei. And even if you did find an Oort cloud, there's a problem in how would you make it under naturalistic assumptions. The idea is that some of those have been flung out. Maybe Jupiter flung some of the original ice in the solar system out to the extremities, but the simulations I've seen of that don't get nearly enough of them out there to make an Oort cloud. So it's problematic if it's there, and it's problematic if it's not there. But since there's no evidence for it, I presume it's not there.
Given the biblical time scale that God created the universe roughly 6,000 years ago, how are we able to see stars and galaxies that are billions of light years away?
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. Well, that's absurd. I mean, you'd have to eliminate the resurrection and turning water into wine and all these things. But the way that I think that God got the light here is I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit of ahead of the other, but it took more time for light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances. And it turns out, this is something that Einstein wrote about, it turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror and bringing it back, and you're measuring the total time, the total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people assume that it takes the light the same time to go that way as it does to go that way. We don't really know that. And in fact, according to Einstein, it's impossible to know that. And people say, why would it be different in different directions? Well, I don't know, but there's no reason why it would have to be the same either. And I found the concept's a little bit difficult for laymen to grasp because it takes a little bit of knowledge of the physics of Einstein. And so I actually wrote a book about this topic called The Physics of Einstein, where it brings people up to speed on the physics that they would have to know in order to recognize why you can't actually objectively measure the one-way speed of light, because you'd need two clocks that are exactly synchronized, and there is no objective way to do that in the universe. There are subjective ways to do it, where you can say, I'm going to call this synchronized, and somebody else is free to disagree and say, no, I don't think they're synchronized. I think they'd be synchronized if this one was turned a little bit ahead of that one, so that now they're synchronized. And the bottom line is, if you use the ancient method of synchronizing clocks, which is a visual synchrony convention, clocks are synchronized if they look like they're synchronized, basically, then light takes no time at all, even today, to get from those distant galaxies to the Earth. And so it can actually arrive instantaneously. And that doesn't violate any physics. It's actually perfectly consistent with the physics that Einstein discovered. It's just that a lot of people don't know about it. And I know that's a little bit abstract. I found that it takes probably at least 20 minutes really to bring people up to speed on the basic issues so that they can comprehend the thrust of the argument. But I do have a series of articles on our website at biblicalscienceinstitute.com. Our latest articles are on this very issue. I've been bringing people up to speed on the starlight issue, some of the other solutions that have been proposed, and why I think this, what I call the anisotropic synchrony convention, is the best method. It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore, there is no distant starlight if you understand physics.
Awesome. That was a great answer. Matter of fact, even going back to your debate 2 months ago with Hugh Ross, he objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? Right. So it appeared that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that specifically?
Yeah. When he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. It depends on what units you choose to make the measurement with. And so whenever anybody asks that question, does it take light 8 minutes to get from the sun to the Earth, or does it get here instantaneously, or 16 minutes? And the answer is, it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate. Everything, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing that we think it is. It's affected by motion, gravity, and things like that. And so the amount of time it takes light, to get from A to B and back to A, that's objective, and that time is objective. And there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it. But the one-way speed depends on how you choose to synchronize clocks. And so does light take 8 minutes to get from the sun to the Earth, or does it take no time at all? The answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention you use. And I believe the Bible's using the more ancient synchrony convention, in which the celestial events are marked by when you see them. And so in using that system, God created the entire universe. The light was immediately visible to Earth on day 4, as soon as God created the luminaries. And that gets around a lot of these other issues too of, people saying, well, God made the light already on its way. Well, then he's making pictures of things that don't exist. This gets around all that, because all the stars that we have pictures of really existed in real time. It's just that we see them immediately.
Oh, I love it. Great answer. We've got a lively chat who are really enjoying this, and who really enjoyed your debate with Hugh Ross a couple months ago, and share my opinions with it. Here we've got Tony Torp. A question came in. Hi, Jason. Has anything been heard from Hugh Ross when you challenged him to read your article, Distant Starlight and ASC, in your last debate? Thanks for your new posts on the subject. They are awesome.
Thank you for that. No, I haven't heard from Hugh Ross. I hope that he did look at that article, because he was under the mistaken impression that light from a supernova could be used to measure the one-way speed of light. It cannot. And I had already answered that, because there was a critic named Peter who had posted that same thing. And I demonstrated that, in fact, Peter had made the assumption in his question that the speed of light's the same in all directions. Otherwise, his question wouldn't make any sense. The fact is, you get exactly the same answer for when you see the light from a supernova that's been gravitationally bent. You get exactly the same answer, whether the light in one direction is instantaneous, or whether it's C, or whether it's any other value that's allowed. And the reason for that is light can only be instantaneous in one direction relative to a given observer. And so the light from the supernova would have to go at an angle. And so it wouldn't be quite instantaneous when it first goes out until it gets bent around the galaxy and then zips directly toward the observer. And so I answered that, and Hugh hasn't got back with me yet. I hope he will. If he wants to, if he thinks I'm wrong, he's welcome to challenge me, and I'd be happy to post his reply and my reply to his reply and so on.
Awesome. Yeah, great response. I mean, it looks like oftentimes I find that the critics, even some of the most militant critics, just aren't really up to date on the literature on this anyways. Yeah. So I guess you kind of answered this, but a question would be, how do you feel the critics have responded to your arguments overall, Dr. Lisle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you. People who are physicists and are trained in relativity have, some of them have said, well, Lisle's right about that. So, and of course, some of the papers that promote an ask type model, like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention. So I haven't seen any real. I've seen internet rebuttals by people who don't seem to be trained in relativity. I've seen one that says, well, no, you can't use that coordinate system where it would create a gravitational field, which we don't see. No, that's not the case. Switching coordinate systems does not create a gravitational field. You can measure things in polar coordinates. You can measure them in rectangular. You can measure using an Einstein synchrony convention or the anisotropic synchrony convention. It doesn't create any magnet or any gravitational fields. And anyway, the most of the ones, if you go back a few months back on my website where I respond to Peter's objections on distant starlight, most of the ones that I've seen on the internet, he repeated those and I answered them. So I haven't seen any ones that are a serious challenge from a physics perspective, because frankly, the conventionality thesis upon which my model is based is really pretty well established. I consider it proved. John Winnie back in 1970 showed that all of special relativity can be done without the one-way speed of light, leaving it as a free parameter, which the epsilon, the Reichenbach epsilon. So I haven't seen any rebuttals at all, really, other than ones that are kind of on the internet, not peer-reviewed ones.
Right. You're going to get that with everybody, though. I mean, you see that everywhere. The internet, of course. The internet's the criticism area. So here's one. You did answer at least the first part earlier, but I'm just going to read the entire thing for you because this was a critic question. So the objectum, for the sake of argument, let's accept that your claim for the round trip average speed of light is 186,000 miles per second. If this is true, and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is no simply no reason to think that the one-way speed of light is over 700 times faster than the round trip speed of light.
Well, when people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying the metric system is clearly the correct way to measure things, and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter, and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razors. Well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system. It is. That's why scientists, we like metric. And we do all our calculations in metric, and then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be, and that will tell you how to synchronize two clocks that are separated by distance. And I know that's counterintuitive, but folks, if you're gonna, if you're gonna argue on this principle, you need to get up to speed on the physics of this. This has been discussed. this topic of the one-way speed of light and its immeasurability has been discussed for over a century. There's a century worth of literature out there devoted to this topic. And not long ago, I came across a book somebody had written. Max Jammer wrote a wonderful book called Concepts of Simultaneity from Antiquity to Einstein and Beyond. And it's a nice summary of the scientific literature written really pretty much at a layman level. And so that's a nice way to get up to speed on these issues. But when people say, well, it's more like the speed light's more likely to be this and than that, or there's no evidence that it's one way or the other. No. This is a convention of measurement. It's a convention by which we decide what we're going to call synchronized when we have two clocks separated by distance. That's all it is. And that's why there is leeway in terms of how you choose to set the one-way speed of light. It's not something that can ever be measured. It's because it's not an objective property of the universe. It's a human choice.
Right. That's a great response. These critics, like you said, Dr. Lisle, they need to get up to date on this. This physics, as you said, is known and it's understood. And it's probably why you have not had any convincing rebuttals. So that's a great response. This is awesome. A couple super chats I should get to. The chat's lively and I may miss these. So $10 super chat from Conservative Christian. Thanks so much. We appreciate it. Dr. Lisle, would SN 1054, the supernova observed in 1054 AD, prove your theory of distant starlight? It was witnessed in real time, meaning it didn't take millions of years for the light to reach us.
Okay, I would say it doesn't disprove my model, but it doesn't prove it either, because if you use the anisotropic synchrony convention, that explosion actually happened in 1054 AD. That's, by the way, the explosion that produced what today is the Crab Nebula. And the Crab Nebula is still expanding, and so we can actually work it back and figure out when it exploded. You get roughly the right answer. We know from history. We know from recorded history it was 1054 AD. And so one of the exercises I have my students do is to try and estimate what that date was, and they get an answer usually pretty close to the right date. But yeah, so that it's just a question of whether that actually happened in 1054 AD or whether it happened previous to that. And that, by the way, that supernova remnant, it's not millions of light years away. That's well inside our galaxy. I don't remember its distance, but it's a few thousand light years away. So even if you assume the Einstein synchrony convention, that would just mean it actually happened sometime probably before Christ's earthly ministry, the actual explosion, and then we finally saw the light from it in 1054. Whereas if you use the anisotropic synchrony convention, then it actually happened in 1054 AD, and we saw the light immediately. So there's no way observationally to distinguish between the Einstein convention and the visual or anisotropic synchrony convention.
Awesome. Yeah, this stuff's so fascinating, Dr. Lisle, and you make it so understandable for us. I want to thank you for that. Question here from Vitalis at SFT for Dr. Lisle. Do you think light is subject to anthropic forces due to a closed system universe?
Anthropic? I don't know what he's referring to. I don't think I understand the question.
No, that's fine.
Of course, we don't know if the universe is closed anyway, so I don't know how I could answer that, even if I understood what he meant by it, really.
No problem. If Vitalis, if you can clarify at some point, then maybe we can get back to that. So the next question, Dr. Lisle, would be, we often hear that cosmic background radiation is evidence of an old universe. What would be the best response to a claim such as that?
I think the best response would be why. How does that in any way prove that the universe is old? People say, well, it's evidence for a Big Bang. I've said, why? The cosmic microwave background, by way of explanation, if you could see microwaves, you could go outside at night and the sky would be glowing faintly with microwaves coming from apparently all directions in space. Now, secularists assert that's leftover radiation from the Big Bang. But how do you know that that's leftover radiation from the Big Bang? You don't know that. All we know about it for sure is that it's there. In terms of where it came from, we don't really know. Now, I don't have a specific creationist explanation for it either, but that doesn't automatically mean the secular explanation is right. The fact is the universe has an average temperature. It is glowing. And that glow appears to be coming from all directions in space, but that doesn't mean it's leftover radiation from the Big Bang. It could be, I don't know, it could be the original light that God created and used for the first 3 days, and maybe he stretched it out. And then it became redshifted to the point, where it's, I mean, I don't know. The interesting thing about the cosmic microwave background is it doesn't really have much in the way of spectral lines in it, except for those that have been imprinted on it by intervening material. And that's interesting because all natural sources of light have an imprint on them of the atoms that made them. That's how we know what stars are made of. We break the light down from the star, and it's missing certain frequencies of light are missing, and that tells us the substance that created that light. It's kind of an atomic fingerprint, and the cosmic microwave background seems to lack that atomic fingerprint, almost as if it was supernaturally created. So I think that's kind of interesting. We don't even know it's a background. It might be relatively nearby. We don't know that. But it doesn't prove a Big Bang. It doesn't, and it certainly doesn't prove billions of years, because we don't know where it started from. And in any case, if you accept my explanation of this as starlight, that'll work on cosmic microwaves as well. They can get here instantly using the anisotropic synchrony convention.
Awesome. Perfect answer. I appreciate that. Maybe this helps clear it up. Vitalis said entropic.
Entropic. Okay.
Autocorrect, I guess, messed that up.
Okay. So does light suffer entropy, I guess, would be the question. Well, everything suffers entropy. Entropy is a tendency of energy to go from a useful state to a less useful state. Things are winding down, so to speak. And that is something that the universe being closed in the sense, it's a closed system. I see what he's going at. The universe is a closed system in the sense that there's no energy allowed from outside the universe. If the universe is all that there is, there can't be energy from outside, accepting the secular view of it for the sake of hypothesis. So yes, everything would be subject to entropy, including light. And so, in fact, when light strikes a substance, it tends to heat up that substance, and then it can re-radiate, and it sometimes re-radiates in lower frequencies. Maybe you get 2 photons instead that are lower frequency, and that would be a higher entropy state. So light, like everything else, suffers the effects of entropy. And what that does is it shows us that the universe cannot be infinitely old, because there are critics who would say, well, we don't need God because whatever created the universe, you have to ask what created that. And I said, well, God's eternal. He has no beginning. So, well, the universe is eternal. I'd say it can't be because of entropy. The universe is an energy system that's winding down. God isn't. God's eternal. The universe is not eternal. Can't be because it's suffering the effects of entropy.
Awesome. And when you were saying earlier that if you were to look up and able to see radiation, would that be similar to like the aurora borealis? Would people be able to see that everywhere? Because that's radiation, right? Or
yeah, it would look different than that. The aurora tend to be concentrated. The aurora are beautiful. I don't know if I've seen them 3 or 4 times in my life. They rarely get down this far, but occasionally they do. Right. And they look like ribbons, and they move and everything. With the cosmic microwave background, it would be almost uniform. It would be kind of the same everywhere, the same color, because it's the same temperature everywhere. So, but it would be something that, yeah, if we could see microwaves, you could see it anywhere on Earth at night. You could look up and the sky would be glowing faintly with these microwaves. And it used to be back when we had the old televisions that got signals over the air that were not digital. And if you turn to a station that doesn't exist and you get all this static on your screen, a small fraction of that is the cosmic microwave background. Interestingly, your old television can pick it up.
That's cool. That's incredible. I heard ants in a microwave do the same thing. They can actually see the radiation and they move away from it.
What's that?
I heard that ants, when they're placed inside of a microwave, can dodge the radiation. They can actually see it, and they move around it in batches, so they can't.
I haven't heard that, but that's interesting.
Yeah, but the next question was, what are some of the major problems with the Big Bang theory? Because I'm sure you hear them all the time.
Yeah, the Big Bang, it's not really much of a theory. I guess you could call it a model, because it doesn't really make testable predictions about the universe, at least that have been specific and successful. Some people think that the Big Bang predicted the cosmic microwave background. I'll sort of grant that, but it wasn't a very specific prediction, because the temperature that it predicted went from 1 degree Kelvin to 50 degree Kelvins, and the true answer of 3 Kelvins is in the right ballpark. But there was, it's like predicting that something will happen tomorrow, and then something happens tomorrow, and you say, see, that's evidence for my hypothesis. Maybe not so much. It doesn't make specific testable predictions that have been vindicated. And in fact, it predicted variations in the cosmic microwave background that are orders of magnitude larger than what we actually see. So it didn't even predict the right kind of microwave background. So it doesn't make good, successful predictions. It's remarkably complicated in terms of all the band-aids they've had to add to it to get it to be consistent, at least somewhat, with the observable universe, like inflation. If you've heard of inflationary Big Bang, that's a patch to try and explain why we don't have monopoles and why the universe has a sort of what we call a flat topology to it. But the Big Bang didn't predict any of those things. So it doesn't make good, it's not a good theory at all. It's at best a hypothesis. And in terms of problems, it's got all kinds of problems with it. One that I like to mention just because it's easy to understand, it's called the baryon asymmetry problem, or the baryon number problem. And basically the way you remember this is you ask the question, where's the antimatter? We can make matter on Earth from energy. We can't make matter from nothing. Only God can do that. But we can take energy from collisions of particles at extremely high speeds, close to the speed of light in particle accelerators. And from that energy, we can create new particles. But every time you do that, you also get an antiparticle. So if you make an electron, you'll also make a positron, an anti-electron, which is the same as electron, but the charges of the particles are reversed. And so according to the Big Bang, the entire universe was originally energy. And then as it cooled, it became, some of that energy became matter. But the problem is, according to everything we know about physics, you should get an exactly equal amount of antimatter. But when we look out into the universe, we find it's essentially matter only. There's only trace amounts of antimatter anywhere in the universe, and they're always produced locally anyway and almost immediately destroyed, because when matter and antimatter touch, they tend to annihilate each other and release energy, especially in the form of photons. But so the fact that our universe is matter only it indicates that it was created not by a natural process, but by a supernatural process, because every natural process that converts energy into matter also produces an equal amount of antimatter. And that problem has not been solved in the secular worldview. I mean, there are proposals for it. The latest idea is that, well, every now and then, one time out of a quintillion, when energy becomes matter, there's no antimatter produced. It's matter only. So but that hasn't been observed. That's just a rescuing device. It's not something that has experimental support. So that's one example. There are many others. There's a flatness problem and the monopole problem, and inflation attempts to solve at least some of those, but it doesn't solve all of them.
Dr. Lisle, you're touching on all the best points here. I read about the antimatter problem. I believe it was in your Taking Back Astronomy book. So great answer there. And you also mentioned inflation. Is this the rescue device essentially for what's known as the horizon problem?
That's right. The horizon problem is a light travel time problem that the secular Big Bang, as it originally was proposed, had. And basically the problem is these microwaves, which secularists assume are the leftover radiation from the Big Bang. Well, microwaves, the frequency of those microwaves tells you something about the temperature of their source. And as I mentioned earlier, that microwave background is very uniform. What that means is the source temperature of everything in the universe was originally identical, or very nearly so. The fluctuations are very tiny. And yet in the Big Bang model, when the universe is supposed to have popped into existence, there's a singularity where all of space is contained in a point, and then it rapidly expands out like a balloon. The surface of the balloon represents the 3 dimensions of our space. And there should be hot spots and cold spots. That's just due to the Heisenberg uncertainty principle. You would have to have, because of the small scale, you'd have to have places that are hot, places that have a lot of energy, places that are cool, places that have less energy. The universe rapidly expands out, carrying the hot spots and cold spots far away from each other. But wait a minute, they're all lukewarm now. Okay, all those temperatures have evened out. And yet there hasn't been enough time for light to travel, and therefore energy to travel from the hot spot to the cold spot to even out those temperatures, right? I mean, if the hot and cold were in contact with each other, they would eventually come to the same temperature, because heat tends to go from hot to cold. That's the second law of thermodynamics. And so you put your ice cube in your hot coffee, eventually you'll end up with lukewarm coffee. They come to the same temperature. But they have to be in contact. They have to be able to exchange energy. And there hasn't been enough time, even if you give them the 13.8 billion years, there hasn't been enough time for light to travel from that hot spot to that cold spot, because they could be on opposite sides of the visible universe. And so the inflation is an attempt to solve that problem, along with the flatness problem and perhaps the monopole problem. But the idea of inflation is that the universe started expanding at what we'll call the slow rate, although it's actually very fast. And then and then it suddenly ballooned out at a much faster rate, and then that inflation phase, that's the inflation phase, and then that switched off and it went back to the slow rate again. And so the idea is that the hot spots and cold spots could have evened each other out right before this inflation phase pushed them far apart. And I'll grant that that could reduce, maybe even solve the horizon problem, but it introduces other problems of its own, such as what would cause the universe to suddenly expand at a much greater rate. Now, there are hypotheses. You say, well, some kind of symmetry breaking in the laws of physics. And then you got to ask, what would it cause it to, how would it stop everywhere? And how would it know to stop everywhere at the same time? That is a huge problem, because there are still small temperature differences. Even today, there are small temperature differences. And so if it's some kind of symmetry breaking, you would think it would turn off different places at different times, but it didn't. We have kind of a uniform universe. And so that's called the graceful exit problem. So the horizon problem, inflation, an attempt to solve the horizon problem, and then the graceful exit problem is a problem with inflation. And some secularists reject inflation entirely because they realize it has its own issues, and they've proposed alternative solutions to the horizon problem. But I think inflation is still the most commonly accepted secular solution to a problem. But as I said, it's got problems of its own.
Wow, great answer. So they say we have a light travel time problem, when in fact they're the ones with a massive light travel time problem. And then based on what you said, in order for them to solve that problem, it turns into a ripple effect of other hard to solve problems. And you pointed out that some authorities on the subject even reject inflationary theory for that reason. That's
yep. And I'll point out too, just in case anybody's wondering,
Yeah.
Did the anisotropic synchrony convention solve their horizon problem? The answer is no, because they need to get the speed of light both ways to be much faster than it really is. Because it's not just the hot spots here that have to get information, have to dump energy to the cold spot there, but it's also a hot spot here that has to dump energy to a cold spot over there. So it has to be faster in both ways. And the anisotropic synchrony convention, you can only have light instant in one particular direction relative to an observer. Now, it could be the incoming direction, regardless of what that is.
right.
So north to south if it's this way, and south to north if it's that way. But you can't have it then going out in that same direction be also instant. So synchrony conventions will not solve the horizon problem. But we have an answer for our starlight problem that is consistent with known physics, and the seculars really don't.
Wow, that's awesome. Great point there. And a couple questions came in pertaining to that answer. Let me see here. Guys, great questions in the chat, very lively chat. I'll never be able to get to all these, so let me at least pick a couple out. Super chat here from Jamie Russell. Thank you, Jamie. Can you explain how the universe doesn't have a center or could be infinite if we started as a point in Big Bang cosmology?
Yeah, entertaining for the sake of argument, the Big Bang idea that the universe started from a point which expands like a balloon. The surface of the balloon, which is two-dimensional, is supposed to represent the three-dimensional nature of our universe. You can think about our universe, if you wish, you can think about it being wrapped around a fourth dimension that we can't perceive. And so just as the surface, there's no one point on the surface of a balloon that is the center, right? And so, there's no unique center. I mean, every ant's walking along the balloon, every one of them could say, I'm in the center, but so could every other ant. But they're actually on the surface of an expanding two-dimensional structure, whereas we apparently live in a three-dimensional structure that's expanding. If you want to think of it as being wrapped around a fourth dimension, you can do that, although it's not really necessary mathematically for that to be the case. So, even though I don't believe the universe started from a point, I do believe it's expanding. I think there's good evidence for that. And the balloon analogy, I think that works for a creationist universe too. It's just God created our balloon with size, and then he's blown it up a little bit since then. Our balloon was never a point. And if that's the case, then there may be no unique center to our universe, or there could be a center. We don't really know. It could be that the galaxies end at some point. It could be that there are a finite number of galaxies in the universe, and that at some point there aren't any, and there's just space beyond that. It could be the case. It could be that our universe wraps around on itself. We don't really know. We don't really know. But any of those are possibilities.
Right. Great answer. Yeah. Like I said before, this is such fascinating stuff. And let me see here. I'll grab this one. I'll definitely get the super chats, guys. So, Jungle Jargon for $5 asks, could the vacuum of space be causing the red shift?
In a sense, that's actually the most common view, actually, because the idea is, when people think of redshift, they think of a Doppler effect a lot of times. Just the way the sound of a car's horn changes as it goes past you, it drops. Light will do that too. Light will shift toward the red. It's much harder to see with light because, well, for two reasons. For one, the speed's just unimaginable. Light is so much faster than anything else we experience. And secondly, our eyes are not analyzers. Our eyes are synthesizers. Our eyes combine wavelengths into a color experience, where our ears don't do that. Our ears can separate sounds into different frequencies. So if I hit two notes on a piano, you'll hear two notes. But if I shine two colors in a circle, you'll see one color. You'll see that combined. So there's a difference there. But with spectroscopes, we can measure the shift of the spectral lines in these galaxies. And the farther away galaxies are, the more redshifted they are. And the initial explanation for that was, well, they're moving away from each other. But probably a better explanation is that you can think of them as being at rest on a universe that's actually expanding. And as the light travels through that expanding fabric of space, it gets stretched out. And so it's in the most popular view, which I think is probably right, that the redshifts are caused not by Doppler shifts, but by expansion of the universe, at least on a cosmic scale. The reason the distant galaxies are redshifted is because of the stretching of the fabric of space as light travels through them. And so, the vacuum of space probably is what's causing a lot of the redshifts, although motion will do it too.
Awesome. I appreciate that answer, Dr. Lisle, and thanks for the super chat, Jungle Jargon. A lot of people enjoying this. Thanks for the conversation. Very informative. So I've got Dr. Lisle's website in the description box, so please check that out for more information on this. This has been awesome, Dr. Lisle. My next question would be, I watched an interview with you not too long ago on craters, and I think it would be a good question and answer for my audience to hear. So I would ask, how best do we explain then craters according to the young biblical creation model?
Well, there's different types of craters. There's volcanic craters, there's impact craters. I presume you're thinking of the craters like on the moon. The interesting thing is, 100 years ago, the craters on the moon, everybody thought those were volcanic in origin. And so the idea that they're impact craters is recent. But now most scientists believe that the craters on the moon, or the bulk of them, were caused by something hitting the moon, boom, and that creates it excavates the material there. And we can simulate that. Well, you can simulate that on the beach. You take a rock and throw it in the sand, and you get a little crater there. So we think that the craters on the moon formed that way. The question is when, and when did this happen? When did all these craters occur? And I don't think there's a creationist consensus on that issue. There are different creationists have different views on it. My best guess would be that during the creation week, that when God created the planets, when he created the stars on day 4 of the creation week, that he may have used process to do that. That he might have made the material for the stars on day 1 and then collected it on day 4 and compressed it into planets and the moon, for example. And so the last bit of material that's being collected to make the moon, that could be what's responsible for those craters. We don't really know. All we know is that all the solid bodies of our solar system have craters on their surface. Most of them have quite a lot of craters, with the exception being Earth and Jupiter's moon Io or Io. The reason Io doesn't have impact craters is because it's so volcanically active. It's been completely resurfaced by the material that's being expelled from its own volcanoes. And Earth, I suspect, doesn't have many craters. The secularists say because of plate tectonics, they've erased it. But I would say it's because it was created by a different process. Earth's made on day 1, whereas all the other objects are made on day 4. And so God may have used a different process. Earth was originally water. The other worlds, we don't know that for the other worlds. They might have been, but we don't know that. So that's a possibility, but we don't really know when the craters happen. But there is good evidence that they're impact craters. The shape of them is consistent with what happens when debris hits material at very high speed.
Awesome. We got another critic question here for you. They feel that this one actually defeats biblical creation, as we know it won't. But multiple meteorites, moon rocks, and Martian rocks dated on location all yield a consistent age of 4.6 billion years, plus or minus a few. this is true across a variety of locations, across a variety of different dating methods.
we don't.
How would you explain this?
We don't have any access for sure to anything from Mars by which we could date it. It's thought that some of the rocks that we collect on Earth that are meteorites may have originally been from Mars. I'm a little skeptical of that. We certainly don't know that's the case. We do have rocks from the moon, and those have been dated using the uranium lead, I believe, method, and perhaps others. And yeah, you do get ages of 4.5 billion years, which you don't get for Earth rocks. Interestingly, you don't get quite as old ages for Earth rocks. So, but the secular thinking is that Earth's been reworked by plate tectonics, and so you don't have original Earth rocks. They've all been reworked multiple times. What's the explanation for that? Well, we think that there's very compelling evidence that the rate at which radioactive decay has happened in the past has been accelerated, and that would account for why there tends to be a convergence on a particular age for rocks that are not Earth rocks. For Earth rocks, you get inconsistent ages. You can take an Earth rock and date it using one method and then date it using another method, and you get different answers. And this has been well documented. John Woodmarappy's book, The Mythology of Modern Dating Methods, documents published dates. These are ones that have been peer-reviewed. They're published in the peer-reviewed literature, to say nothing of the dates that were inconsistent and therefore never published. I mean, think about that. Think you're a secularist and you date a rock and it gets you an age that's way off what is expected to be for that formation. Probably you don't publish it. You say, well, so obviously something went wrong there. And so the fact that you have inconsistent data, even within the literature that was published, suggests that there's a far greater number of inconsistencies that have not been published. The Rate Research Project, too, in their book, they also documented. There's a chapter on the discordant date. So it's not as consistent as you've been led to believe. Now, I do think it's a little more consistent for moon rocks because they haven't been reworked. There was no worldwide flood on the moon. And so whatever process God used to make the moon apparently was pretty uniform. And so even though the decay rates have been accelerated, there's good evidence for that. Read the rate research on that. Presumably it happened at a uniform rate. And so that's why you get some degree of consistency with moon rocks, but very little consistency with Earth rocks.
Yeah, there probably is some kind of maybe enhancement of the decay rates. For example, here's something. When they went to the moon and they got one of the first moon rocks and they brought it back, I forget the exact number of what they identified it as. They didn't actually call it a specific rock. They gave it a number. Oh, here it is. Lunar sample 14321. It dated at 4 billion years old. But when they tested it, it was actually a piece of driftwood from Earth. But the oldest tree dated is 350 million years ago on Earth. So how could that even be a thing? I'm just curious if you've ever heard about that or considered.
I haven't heard about that specific one. I have heard of examples of, for example, wood that's embedded inside rock. Volcano will come, uproot trees, lava will flow over it. So you have wood embedded in rock, and the rock dates to millions of years and the wood dates to thousands of years. So that's a problem. And in case people are wondering, when you date a rock, it's supposed to tell you when the rock hardened, because before that everything's liquid. The minerals can move in and out, but when it solidifies, then that's supposed to trap the parent and daughter elements. And so the only way you get daughter elements is by the conversion of parent elements. And yet you get wild inconsistencies. So inconsistencies in radiometric dating is not new. It's well known. And we've taken rocks from Mount St. Helens, brand new rocks, sent them into secular labs to have them dated. You get hundreds of thousands of years on brand new rocks. So we know radiometric dating does not work on rocks of known age. It's assumed to work on rocks of unknown age. And I think that's not very scientific.
Yeah, matter of fact, you mentioned accelerated nuclear decay. So if this was occurring maybe during the flood or even during the creation event, would this have also made these dates unreliable?
Yeah, if you assume that the decay rate is constant, when in fact it was faster in the past, your ages will be inflated. And they'll be inflated by the degree to which you assumed that something was constant, divided by the rate at which it was accelerated as a rough measurement. So if the decay rates were millions of times faster during the flood year, for example, and there's very compelling evidence for this, because the fact is when uranium, for example, when a uranium atom it decays into the next element, which decays into the next one, all the way down to lead-206. For every one uranium that turns into a lead-206, it emits, in that process of radioactive decay, it emits 8 helium nuclei. So it produces helium as a byproduct. And helium is a gas, and rocks are porous. And so gas can leak through rocks. And it doesn't take millions of years for that to happen. And so the bottom line is, if the rate at which the uranium turned into lead had always been the slow rate that it is today, that the helium that's produced would have had plenty of time to escape. There should be very little helium in these rocks. And the research team found that there's abundant helium trapped inside these rocks that have radioactive elements in them. And it's consistent with all of that decay having happened in the recent past, thousands of years ago. Now, there is a temperature dependence in terms of the rate at which the helium leaks through. But in order for it to accommodate the data in billions of years, the temperature would have been close to absolute zero, which is absurd because the temperature actually gets hotter as you go in toward the Earth, because the Earth has a molten core. So they're compelling evidence that the radioactive decay rates were much faster in the past. There's been this opinion in the last few decades, well, previous to the rate research and a few other research projects by secularists, actually, there was this opinion that radioactive decay rates cannot be influenced by any external parameters, because when you do chemical experiments, it tends not to affect the radioactive decay rate. But we now know that it's false. There are some ways of accelerating certain kinds of radioactive decay. For example, the rhenium-osmium reaction has been sped up in a laboratory by a factor of 1 billion. And all you have to do is strip away the electrons from the rhenium, and it will decay much, much more quickly. So, and that's one method. That's a method we can do. God obviously has options that we don't have. God could change the nuclear strong force by a bit, and that would change the rates of decay and so on. So there are different ways in which radioactive decay could be accelerated. We think there's good evidence that happened during the flood year, and that would explain why the secularists, not including that factor, get ages that are far older than the true age, including on things whose true age is known, because it happened in recorded history, for example.
Makes sense. Do you think that this accelerated nuclear decay would have caused what they deem as the heat problem? They said, this convection and the subduction plates would have caused so much heat generated during this nuclear process that the oceans would have boiled. Have you heard of this? Do you have an answer?
Yes, I've heard of that. Yes, I haven't seen a detailed study on that, other than there are ways to dump the heat. First of all, you need heat. You need heat to start the flood. So that's not a bug, that's a feature. To get the plates moving, they need energy, and an acceleration of radioactive decay, that's a great way to start plates moving, to heat them up to where they can be hot enough where they could be almost not quite a liquid state, but it makes them more malleable. Where did the heat go? Well, we don't know. First of all, we don't know what the Earth's temperature was in the core, for example, before the flood year. What if a lot of that energy is now, what if it's still there? What if it's still in the core? A lot of the energy could have gone into that. A lot of the energy could have been dumped to space. There have been creationist models of hypercanes, for example, which is like a hurricane, but on a much more massive scale. Hurricanes are very good at dumping heat, dumping energy to space. When a hurricane goes over the ocean's temperature drops by 10 degrees. And that's a piddly hurricane. Imagine a hypercane that's taking all this energy and dumping it into space. Convection is a great way to move heat quickly. It's the best way to do it. And we think there was a lot of convection during that flood year. So there probably were spots on the ocean, hot spots that boiled. There probably were. But as soon as they get to the air and they spray up, and then they lose that heat and so on, they lose it to space. So there are lots of ways of dumping the heat, and perhaps a lot of the heat is still in Earth's interior. Since we don't know what the original Earth's interior, we don't know how hot it was to begin with. Some of the energy could have gone there. There are other explanations for that. I don't have the numbers with me to see, which of these is the most plausible, but there are some possibilities right there. So certainly it's not a knockdown, drag-out argument against a accelerated decay because it produces heat. That's a feature. We need some heat to start the flood, and as long as you can dump it to space fast enough, you're going to be fine.
Right. That was a really good answer. Probably one of the best I've heard on that specific criticism from your critics that say there's an unsolvable heat problem. And I've seen you, Dr. Lisle, speak on accelerated decay quite a bit. I saw you brought up the helium and zircons in a debate you had with Dr. Ross, but this was one, I think, years ago where Frank Turek was moderating.
Mm-hmm.
And I wasn't exactly thrilled with Hugh's response. I think you got him on that one real good. And I guess you did kind of just answer this actually, but the question would be what are some of the best responses to critics who say, because I constantly hear them still continuously repeat this, even though you just gave a huge number of overwhelming lines of evidence suggesting accelerated nuclear decay has occurred, but they still say, nope, this isn't possible. It's never been observed in the lab. What's a good quick response to these critics who make that
Well, it
claim?
has been observed in the lab. There's no doubt about that. Have them look at the rhenium-osmium reaction.
Right.
Bound state beta decay. You can make that rhenium decay 1 billion times faster than it does in normal circumstances in nature. And granted, I'm not suggesting that that's the solution to all of them. I'm not suggesting that that all the material was ionized and things like that. But my point is, if you want to blow away this assumption, the assumption that radioactive decay rates are always constant is false. It's demonstrably false. That has been disproved in a laboratory. Now, that doesn't automatically mean that decay rates were faster in the past, but it does mean that that's a possibility. It's not something that can be dismissed out of hand. I do think the helium in the zircons is just, I don't know how secularists sleep at night with that data, because how do you explain that? In billions of years, there's been plenty of time for that helium to escape. We know the rate at which it leaks through rocks. That's been measured, and there's just no way you can make sense of that. I'm not an evidentialist, but at the same time, I don't see a good rescuing device even for that.
Right.
So I think the evidence is very compelling for accelerated decay, and in any case, we have tested radiometric dating on rocks of known age, and it often gives the wrong answer. So that immediately, as a scientist, just somebody being an objective scientist, you should say, we really shouldn't have a lot of confidence in that method because we know it gives wrong answers on dates of known age. So it doesn't make sense to trust it on dates of estimated ages for things whose origin is not known.
Right. I think you nail it with that, Dr. Lau, where you say we don't get accurate dates from rocks of known age, but yet they want us to trust the rocks of unknown age and the dates. It just seems common sense not to. Yeah. So right here, super chat came in. Logical, plausible, probable. Thank you. $5 super chat says, is any plausible explanation offered for Earth's 332 million cubic miles of H2O offered by secular science? Are that many impacts probable?
That's a really good question. Not that I've seen. The earliest explanations were comet impacts, and the thinking was that perhaps the early solar system had a lot more impacts. By the way, we all agree that the rate of cratering was much faster in the past. Secularists believe that, creationists believe that. So the rate of cratering isn't constant. The early solar system, whether it experienced some kind of catastrophe, whether God used process to create the worlds, which would be my explanation, either of those, the rate at which cratering happened in the past, much faster than it is today. Every now and then you get a new crater on the moon, something will hit it, but it's pretty rare today. Comets were the original explanation for the Earth's water. But I think it's the deuterium ratio in comets does not match the deuterium ratio in Earth's water. So a small fraction. So water, H2O, the H is hydrogen. A small fraction of that's deuterium. So it's got an extra neutron. Most hydrogen, no neutrons. And the deuterium ratio in comets does not match the deuterium ratio in Earth's oceans. And so that really puts doubt on the possibility of comets being consistent, being the source of Earth's water. And so then the alternative explanation, and this is the latest that I've heard, is that asteroids would deliver Earth's water, because you can find small traces of H2O in asteroids and meteors. And supposedly that deuterium ratio matches the Earth's oceans better than comets. But my question would be, then why doesn't Venus have liquid water on its surface? And why doesn't Mars have abundant water? Right. It's got some water molecules on it, but Earth's just covered with water. If you even out its features, it'd be covered with water to a depth of 1.6 miles. Venus, not a drop, and not even much in terms of water vapor. There's probably some, but not much. It should have been hit by just as many asteroids or comets as Earth in the early solar system. So I think if they find an explanation, it's going to be problematic, because why didn't it happen on Venus, Earth's neighbor?
Right. Yeah. That was a great question and a great answer. I find it funny because a lot of times you'll hear the critics say, you know, where's all the water? Where's all the evidence for the flood? It's like, have you not seen the earth? Like,
Yeah.
have you not seen all the water in front of your eyes? So here's another super chat. Jamie Russell, $5. Thank you so much. I appreciate it. Does the redshift explanation conflict with the one-way speed of light? Does Dr. Lisle think meteors could have come from Earth? Happy Thanksgiving. Happy Thanksgiving to you too, Jamie.
To the second question first, no, I don't think meteors are made up of different types of material than is commonly found on Earth. Meteors have more iridium and things like that in them. Now, the first questions, the answer to that is no, it doesn't conflict with the one-way speed of light. But I can see how you think that. That's a very I commend you for asking that question. That's a very insightful question, because if we say, well, the reason that the redshifts happen is because the universe has been stretched while the light's traveling, doesn't that require a finite speed of light? And the answer is amazingly no, it doesn't, because the expansion. When you talk about the one-way speed of light being instantaneous versus being the same in all directions, what you're really doing is you're using two different coordinate systems. And so the results of any experiment have to be the same in terms of what you actually get. And so if light is redshifted in one system, it has to be redshifted in the other system. The cause might be different, but the degree of redshift will be exactly the same. And there's not an easy way to explain this without going into general relativity, but there is a general relativistic time dilation that occurs for galaxies that are far away under expansion, and that accounts for the redshift, and it will match the redshift that you would get from expansion of the universe under the Einstein synchrony convention. So it's not easy to understand that without knowing relativity, and relativity is not easy to understand, which is why I wrote a book on at least special relativity. But that's a very insightful question. So no, it doesn't conflict. You get the same answer because you're just switching coordinate systems.
Awesome. Well, thank you for that answer, Dr. Lisle. I managed to get all the super chats. Matt, I think you had one last question you wanted to ask there, brother, a couple comments you wanted to make.
Yes. It is not related to astrology like we've been on, so it's kind of we're going to jump over to this unrelated topic, but it involves a paper that you co-authored with Nathaniel Jeedson on the origins of eukaryotic species, genotypic and phenotypic diversity. I can speak for both Standing for Truth and I when I say that we definitely is one of our favorite papers, and we recommend that the critics listening, and non-critics, of course, all go and read that. It shows that the created heterozygosity, together with the operation of natural processes that can be observed today, is sufficient to account for the species phenotypic and genotypic diversity. Can you briefly touch on that, what you wrote?
Yeah, and Dr. Jeanson's the genius behind the paper. I just did some computer modeling for him, but I thought it was very generous of him to attach me as a co-author. But I ran some computer simulations that confirmed what he had predicted based on so heterozygosity. So you have two different, at a given locus or site, you have two different genes there, two different alleles, so A and B, and so your blood type's A, B. And it turns out that you can account for the current different breeds that we have, the different varieties in organisms that we have, by assuming that the original kinds were highly heterozygous, lots of, A, B, and so on, rather than AA, or homozygous. And so you can account for the different variations that we see in nature that way, just by allowing them to reproduce and to go and multiply. And so you get a combination of genetic drift and natural selection, where certain traits get concentrated into a certain group of organisms. And if those traits are conducive to survival, then the organisms tend to survive better. And so they tend to carry that particular combination of traits. And so you can account for the different species that we see in the world today. You can account for speciation this way. And it's consistent with what we find in the fossil record as well. And of course, genetic drift as well. Genetic drift would be the same kind of thing, except there's no particular survival advantage. It's just this particular group of organisms, dogs, for example, this particular group has blue eyes, and that doesn't really convey any survival advantage over brown eyes, but it's just whatever group happens to have those features, and then they reproduce, and so that gets locked into the population. Dr. Jeans can explain the details better than I can. I just did the computer modeling that showed how this worked out in terms of the number of species that we'd expect today, and that the speciation rate is approximately linear over time. So you continue to get speciation over time.
Yeah, his work is extremely technical. It's great stuff. His Replacing Darwin's great. So unless there's more questions in from the audience, I can jump into another one.
Yeah, I was. Oh, I'm sorry, Matt. Go ahead, brother.
No, I was just going to say that just yesterday they actually found out that you might like this. Mars has an active volcano on it. So
really, I hadn't heard that.
Yeah, that's yesterday. They posted it. Brand new information. So
That's cool. Creationist Ron Samick predicted that.
Really?
Great.
Oh, wow.
Yeah.
Nice.
Well, there you go. They like to say that creationists don't make future testable predictions, but there's yet another one right there. And the answer to the previous question, Dr. Lisle, was great. Yeah, we definitely love that paper, and we appreciate the answer to that. I just find it funny that the critics like to say that, we as young Earth creationists, we could never get all the species we see today in just 4,500 years. But as you pointed out, if we're starting with heterozygous ancestors, those DNA differences are already built in. So
Right.
you just shuffle up those DNA differences, you can get new varieties quickly.
Yep.
So we have been going over an hour, and you have done a phenomenal job, Dr. Lisle. People have really enjoyed this. We've had a lot of great comments, great questions. As kind of a final question to wind down, and you've had a lot of technical questions here too, Dr. Lisle. So thank you again. This has been awesome. I've got so many notes because you brought up so much good information, good points. Earlier back in the interview, you mentioned carbon and how carbon is found in diamonds, coal, fossilized wood, I believe as well. Mm-hmm. Have you personally, have you been convinced, or have you seen any good rebuttals to why that is?
The best I've seen, and it won't work, the best I've seen is that there's other nuclear material down there that can recharge the C14. But the rate group looked into that, and they estimated that you'd need 13,000 times more radioactive material in these rocks than is actually found there in order to adequately recharge the C14. And when I recently debated Hugh Ross, that he thought that was the answer, and I pointed out to him, no, you need far more nuclear material. See, the idea is, so C14 decays quickly. C14, we find it in diamonds, we find it in coal, and these are buried deep down in the earth, because normally the way C14 is made is in the upper atmosphere. When cosmic rays strike, they cause a cascade that transforms nitrogen into C14. But deep down in the earth, the cosmic rays can't penetrate that far. They can't go very far into the earth. They're very high energy. They can't go deep into the earth. And so the idea is the C14 that's in anything that's deep down should simply decay away. And the half-life of C14 is 5,730 years. So it doesn't take millions of years for this stuff to decay away. And the idea is that the secularists have proposed that perhaps radioactive material could create the free thermal neutrons that could then create new C14 in these substances, recharge them. That C14 that's turned into nitrogen, turned back into C14. But the problem is the rate of radioactive decay of these other substances is much slower than the rate at which C14 decays. And so a typical element might be, say, 100,000 times slower than C14. So you get C14, boom, boom. It's emitting 100,000 conversions in the time it takes this element up here to turn once. And potentially one of those could recharge one of the nitrogen atoms back into C14. But that's not going to work, because these things are popping off like this, and then every now and then one of them gets recharged. That's not going to help. That's not going to keep it supplied with such a vast quantity of C14 that we do find in these things. And so you'd expect in order to have some kind of equilibrium where the C14 is continually recharged, the amount of other nuclear material would have to be greater in proportion to carbon, roughly relative to their the ratio of their half-lives, which is enormous. It's a factor of 1 million or so, depending on the element. So it's not going to work. There's no way you can recharge that deep down. I think the reason some people assume that that's happened is because I think they found evidence that places that have extra nitrogen, you also find more C14 there. But that's a prediction of the rate research group, because if you have accelerated decay, that will happen, because with accelerated decay, that uranium can decay into lead much, much more quickly. And we think that the longer half-lives were shortened by a much greater ratio than half-lives that are already short. Like carbon-14 probably wouldn't have been affected very much by accelerated decay. And so that is going to do it, but it's only going to do it during the flood year until the accelerated decay shuts off, and then it's not going to happen anymore. So other than that, I haven't seen any good answer to the evidence for the fact that we find C14 and just about everything that has carbon in it, in contrast to what you'd expect if the Earth were billions of years old.
Yeah, that's an amazing answer. Yeah, I guess I could say I was not thrilled again with, because you mentioned that that argument was brought up in your latest debate with Dr. Ross, and that's right. I mean, it's not a very convincing argument, and even with the diamonds, there's the hardest substance on Earth. So any rescue device with contamination or anything like that, it wouldn't work, right? Wouldn't that C14 found in the diamonds, it'd have to be there from the beginning, wouldn't it?
Right. I have heard people claim contamination, but that's just ridiculous. So the people that run these labs, they know how to clean the surface of the material so that it's not contaminated. They can put in a blank sample and you get nothing. So they know how to they know what they're doing, and they're getting answers, and the answers are right. They're just not what the secularists would expect.
Right. Yeah. No, it's fascinating evidence, and God did not have to provide us all this evidence, in science, and yet He did. So, as the Bible says, it always brings to mind, that they are willingly ignorant, because the evidence is overwhelming. And so, I guess as a final question before we shut it down here, you also mentioned Earth's magnetic field and how it's decaying and it limits the age of the Earth and the universe overall. Have you been convinced at all then with any counters to that one? Have you seen any? Is this more so just a rescue device as well now that they're employing?
Yeah. The rescuing device there is that the Earth's magnetic field recharges itself in a magnetic dynamo, and there's problems with that. We know, for example, that the sun flips its magnetic field every 11 years. And that's well documented. And it does that because it's rotating differentially. It's gas. It can twist itself up, and it's constantly doing that because it's a ball of gas. Earth, not a ball of gas. And so it doesn't rotate differentially. And so we would not expect Earth's magnetic field to be flipping today. Now, during the flood year, all bets are off. The plates are moving at rapid speeds. And so we do think the Earth's magnetic field flipped rapidly during the flood year and perhaps subsequent to that. I've done some of my own research on how that would affect the production of C14 in the atmosphere due to the fact that the Earth's magnetic field blocks cosmic rays, which produce C14. I haven't published this yet. It's just I'm still sitting on it, but seeing kind of what it means. But yes, the Earth's magnetic field's complicated. It probably did flip multiple times during the flood year, but there's no evidence that would recharge the magnetic field. None whatsoever. As far as we can tell, that would have just caused it to decay even faster. In terms of losing energy, as far as we can tell, the Earth's just been losing magnetic energy since its creation about 6,000 years ago. I haven't seen any compelling evidence to the contrary. And these dynamo models, they're full of holes. And they require that the magnetic axis be aligned with the rotation axis, which for the sun it is. Earth is close. Uranus and Neptune way off. And yet they have magnetic fields that should have decayed if they were really billions of years old. And so I'm not remotely convinced by these dynamo models. But if you've heard of a dynamo model, that's what it is. It's an attempt to try and get the magnetic field of Earth to recharge itself. And they think that continues to happen, that it'll continue to flip. We think it's probably done flipping. That was something that happened during the flood year. There's no mechanism to do it today.
Yeah, it makes sense. Yeah, that's one of their rescue devices is all of the magnetic reversals help, but we found that it's been pretty rapid. So, and here's another one too. They found Zychron crystals with helium in it as well. And I mean that's one of the oldest things that they date on Earth. So, yeah, shouldn't be there.
Yeah, and I'm sorry. I was just going to point out. It was my understanding, like you said, the rapid magnetic reversals at the flood. It was my understanding that I think Dr. Russell Humphreys even predicted that or pointed out that might be what would be expected, and yet that was what was found.
Yeah, he's done a lot of work on that, and brilliant work on that. I think I really appreciate his work on not just the Earth but on planetary magnetic fields, and really interesting because there's an expected amount of magnetism you'd expect when the worlds were first created. Based on Humphrey's model, and he gets the right answer for all of the planets, including Earth. And Earth's if you include that flipping, it causes decay a little faster. You get an answer that matches up with what we observe. So I think it's brilliant research.
Yeah, awesome. Well, this has really flown by. Dr. Lisle, I want to thank you for your time. You've been an incredible blessing to this channel, to us, to the audience, and Christianity as a whole. Your defense of the faith is it's a blessing. It's amazing. So I want to give some final words to you, Dr. Lisle, before we shut it down for the day. And thanks again for giving us your time.
My pleasure. Thanks for having me on. And if people want to check us out at the Biblical Science Institute, that's a free website, biblicalscienceinstitute.com. Lots of free articles on there for you. We got a podcast. I've been reviewing my own debate with Hugh Ross, things I could have said better maybe, and things that I didn't have a chance to respond to and so on. So that might be fun for you to look at as well. And lots of books on our website as well. So please check that out. And thank you very much for inviting me on your program. I appreciate it.